Hey guys, I just wanted to review graphing exponential functions. So you have two assignments on Delta Math. One was on graphing specifically exponential, and one is on graphing logarithms. On Friday, the assignment is going to change to completing the second page of the worksheet we started on Wednesday, as well as doing a mixed variety of these types of problems. So I just wanted to briefly review how to do these. Firstly, the exponential function is y equals a times b to the x power, where a is our y-intercept and b is our scale factor. So looking at the example we have here, we have a y-intercept of -3 and a scale factor of 1/2, meaning this graph is decreasing. So if I go to the graph here, keep in mind that there's a horizontal asymptote with all exponential functions, meaning at some point, with an exponential function with a b value that's getting smaller than 1, it's going to be a decaying function, meaning at some point you're dividing by some number. At some point you just can't get to 0. So the classic asymptote is going to be at 0. So we're going to drag this up to 0. And then our y-intercept is going to be at -3. And then because the scale factor is 1/2, that means our second point would be at 1.5. Now, because of the way this program works, it's not really possible to plot that point, so I'm going to plot the opposite point on the other side at -6, meaning that I am dividing by 2 as I go to the right. So going from -6 to -3 is dividing by 2. All right, now, that is this function ignoring the -4. So the -4 is a shift. It is a vertical shift. So we're going to shift everything on this graph 4 units down. So this is going to go to 10. This is going to go to 7. And then this is going to move to -4. So the asymptote is now y equals -4. So that was the correct answer. They show the graph. Now, if you're given the graph in a different position and you're asked to identify the equation of the graph, we'll take a look at another example in a moment. So I'm going to look for another problem that's an exponential function. I'm just going to look at the answer. So this is what the graph is. And if I wanted to figure out what this equation was, what I would have to do, let me try a different one. Looking for an exponential function. Okay. So if you look at this graph, because it's shifted, it's kind of hard to tell what the y-intercept and the multiplier are, so we have to kind of figure out where those are. So what I'm going to do is I'm going to just kind of sketch the graph here because I need to be able to draw on something. And we have our asymptote here. This point is going to simulate our y-intercept, and this other point here is going to help us find our scale factor. So this is the graph. So if I were to draw a different set of axes to make this the y-intercept and make this the x-axis, that is 1 unit above where the axis would be. So this would be like a y-intercept at 1. The scale factor is what do I multiply 1 by to get up here, which in this case would be 3 units above. So this is 2 units, 3 units above the asymptote. So that means it's 1 to 3, which is the scale factor of 3, to the x power, and then I just have to acknowledge that there is a shift of some sort. In this case, there is a shift 8 units to the left, because you can see the y-intercept is actually on -8. So we're going to put a +8 here to move the graph 8 units to the left, and we'll notice that the asymptote is 4 units above the x-axis, so that has a +4 to indicate that. So you can either find the graph, you can find the equation from the graph, or you can graph just using the equation itself. So let's take a look at some details for logarithmic functions. So a logarithmic function is y is equal to log of some base b to the x. And if you wanted to include stretches, you would include an a. If you wanted to include a horizontal shift, you would put an h inside of a parenthesis with the x. And if you wanted to include a vertical shift, you would put a k. And the vertical asymptote of a logarithmic function would be at x equals h. So let's try an example that is a logarithm. So this one here is at -2 log of x minus 1 and minus 6. So firstly, it has a vertical asymptote. Let me see if I can get the asymptote button to work on here. I was having some issues with it earlier. That's why I started the video with the asymptote already chosen, because I was having the issue. Let me click this button, please. All right, so I managed to click the vertical asymptote. So that's the first thing. A logarithm has a vertical asymptote. The average logarithm will have a vertical asymptote at 0. These 2 points exist on every regular logarithm. Those points are going to be 0, 1, and the reason for that is, if I were to rewrite that in exponential form, what it says is b to the y power equals x, and if I put x in to be 0, the value that will give me that value is 1. So for any logarithm that hasn't been shifted, the point 0, 1 will be on that graph. So the first thing we're going to do is plot 0, 1. Secondly, the point 1, the base, will be on that graph as well, and that's because b to the y will equal to 1. I'm sorry, I wrote that wrong. B to the y will equal x. When x is 1, oh no, I wrote this wrong, I'm sorry. Let me go back a little bit. When x will be 1 when y is 0, so this point should be 1, 0, not 0, 1, excuse me. 1, 0. So the first point that's on every exponential, every logarithmic function is 1, 0, because when x is equal to 1, y had to be 0. The second point that's going to be on there is going to be its own number and 1, and the reason for that is b, the y, will equal to b when y is 1. Okay? So we're going to, in this case, we're looking at a base 2, so that means 2, 1 is going to be on our graph. Now, if there is a vertical shift here, in this case the a value, then the y value here will be multiplied. All right, so all the y values will be multiplied. So this would be a0 and a1. So in this case, the a value is -2. So instead of being at 2, 1, it will go from, instead of being 2, 1, it will become 2, -2, because it's being stretched vertically to -2. The other point doesn't move because that point is at 0 and 0 won't multiply. Next, all we have to do is apply the shift. Now, the shift in this case says x minus 1, which is a shift of 1 unit to the right. So I'm going to move this point 1 unit to the right, and this point 1 unit to the right, and move the asymptote 1 unit over as well, making the asymptote x equals 1 instead. Next, we're going to move the graph 6 units down. So this was at -2, so I'm going to move it to -8. This was at 0, I'm going to move it to -6. And that should be the correct logarithm. All right, if you have any questions, make sure to ask them, and I will see you guys on Friday.